Go. All right, so with all that being said, we just started. We are going to have our piece of paper and writing utensil out. We're going to take a look at these stacks that we have. And notice I said, how would you organize the following to have the least amount of piles as possible? You want the least amount of piles as possible. So what would you do to make the least amount of piles as possible?
Put one pile on the other pile.
Yeah. And which piles would you put together?
9 and 7 and 11.
You put together 7 and 11. So I'm going to circle in blue 7 and 11. Any others?
10 and 5.
He says 10 and 5. I'm going to do it a different color.
8 and 12.
8 and 12. Anybody, does everybody agree, or do you see that we could make this even? You're on the right track here, Keaton. Looks like he's just putting like things in piles together. Do we have any other things that are like what I've circled in green, blue, and red? Grace? Yeah, you got it.
That's what I was going to say.
Okay. Oh. Keaton says that's what I was going to say. So yes, we have 3 piles of peanuts. This is kind of like making our trail mix. We're making a trail mix right now, okay? But we like, we're going to separate our piles for our trail mix to start. You can see I used more M&Ms because who doesn't want more M&Ms in their trail mix, right? And then you notice we only have 1 pile of raisins because who really likes raisins in their trail mix? Maybe some people do. I eat them because I should eat them, not necessarily because they're my favorite or I like them. So as you look at this, you can see we put all the like things together. And when we put all the like things together, we end up with a certain number in each pile. And I have that down here. So in other words, when I add this total amount of blue M&Ms, I had 15 of them. I had 20 green M&Ms, and so on and so forth. Now they are organized and they are efficient and simplified, right? That is combining like terms, right there. It's just that instead of having piles of M&Ms and peanuts and raisins, we have x's and x squareds and x to the thirds or x cubes. That's the only difference. And, no, I should take that back. And sometimes we have negative amounts of them, okay? But that's what you're doing is organizing piles of like terms. Remember, like terms have the exact same variable. In other words, we had 2 different kinds. These looked very close. The M&Ms looked really close, but one was blue and one was green, so they weren't exactly the same. Just like here, I can have x's or I could have x squares. Now they're both x's, but one is a power and one is not, so therefore they are not exactly the same. Okay? It's only the ones that are exactly the same that can go together. And don't forget that the sign out in front is what goes with it. So if I'm circling these to say these piles are the same, I'm going to put them together. You better circle the sign that's out in front with it so you know what 2 numbers you are adding together to find out the total amount of x's. Okay? What do I do with these constants out here? What if I had more constants on the end? Are these a category or a pile? Yeah, these are kind of like the raisins. And if I have another number out here, that's still a raisin. So these are all constants. All the constants will go together. Okay? We know that the numbers out in front, which are called coefficients, if you remember from the Quizlet yesterday, these terms were in there, but these are called coefficients. That is what I am going to use to decide how many are going to be in my piles of x's. Okay? So let's just do a quick little review here. I want you to, on your piece of paper, take a look at this 72p minus 25p and tell me how many P's do you have. And again, you should have your calculator ready, so use your calculator if you need to. But the first thing you have to decide is, are both these piles exactly the same? Are they both blue M&Ms? Are these both blue M&Ms?
No.
Oh, Keaton wants them to be purple because they're a P. So Keaton, are they both purple M&Ms?
No.
Are these both purple M&Ms? Yeah. They're both, the P is exactly the same. Since that is exactly the same, they go together. You put the piles together. And again, please make sure you take the sign that's out in front. Now here's what I need from you. We need to come up with a way that we are going to decide which things go together. I would prefer that we underline and squiggle, just because when we start circling and triangling and those kinds of things, it can get more messy, and we can get mixed up with signs. But again, you have to do what works for you. The thing you have to remember is just to take the sign that's out in front. So if I have 72 purple M&Ms minus 25 purple M&Ms, how many M&Ms do I have in this purple pile? What did you guys get? What did you get? 47. But don't forget, you got to tell me what's in your, what it is. It's purple M&Ms, so 47P. Okay. Now look over at the other problem I have written there. The first thing you have to decide is, are those the exact same piles? Are those both like terms? I don't know. Are those like terms? Can we put those piles together? Are they exactly the same? No. Now they might both be M&Ms because they're both T, but one of these is a different color M&M. So these cannot be put together, so you just leave them alone.
Teal M&Ms.
Okay? Teal M&Ms. Okay. He's having a lot of fun with his M&M colors. Here we go. You've got a couple more problems. Let's write this one down, or look at this one. 0.5m plus 2.5n. Again, so Keaton says we have maroon and neon. We have maroon and neon. Those are not the same. Okay? So we can't do anything with it. Again, don't worry, the numbers out in front, please don't let that scare you. All you're doing, remember, is you would just combine those numbers and you would just add them if they were the same. How about over here? We're going to call these M&Ms. They are both M&Ms. Are they the same color M&M?
No.
Not really. Why not?
Square and cube.
Yes, there's a squared and there's a cube. So again, they are not exactly alike. There's a little something different, so we can't do anything with it. Like terms versus not like terms. Now let's go down here. Now we're playing a little bit more. Write this one down. 8m minus m minus 3m plus 5. The first thing we need to identify is, are there like piles that we need to put together? Yes, there are. And see, you guys already are doing a good job with that. Okay, so I'm going to underline all the like piles. Now I have to decide how many are going to be in this pile. Well, there's 8 in this pile. That's easy to see. How many are in this pile, the second one? What's the number out in front? You're like, there is no number. There's a number. It's 1. Yeah. We're going to put the 1 out in front. Okay? And don't forget, the sign goes with it. So right now we have 8 minus 1, and then we have minus 3. On your calculator, you would go 8 minus 1 minus 3. Or you would think 8 minus 1 is 7, 7 minus 3 is 4. Don't forget you have to tell me how many, or what, sorry, what is the term, what is the pile, and how about this guy out here, the plus 5? Any like terms for that one? No. So I have 4 total m's and then plus 5. Okay, you do this last one over here. Let's see what you can come up with. Let's underline and squiggle the like things to know what we're going to put together. So the first thing I'm going to do is look at this first term here, x. Are there any other x's that should be with that pile? Which one? Which one should go with the 1x?
6x. With 3x.
The 3x. Remember, this has to be exactly the same. Okay? What I like to do at this point is I like to rewrite that and put those right next to each other. X plus 3x. I want those piles next to each other. Okay, now let's look at the negative 6x squared. That's where I'm going to use that squiggle line. Is there any other things that should go in that same pile? Yeah. And so we're going to squiggle line that. I'm going to rewrite that so it's right next to each other. And you guys go ahead and finish. Tell me what is your final answer here. Remember, take the sign out in front with it. And online learners, be prepared. I'm going to ask you. One of you is going to give me the answer, but you're going to have to raise your hand, please. Online learners, make sure you're doing this problem. And if you have the answer to it, go ahead and raise your hand when you're done. And the way you raise your hand is you go here to more. Okay? Don't you? I don't know, where's your hand raised? It's in there somewhere. Yours may be a little different than mine. And that's going to be somebody besides JT. JT is always answering questions. I need somebody else. I just told you why. All right. Online learners, here we go. Colton, before you go, you're going to answer here. What did you get when you put these piles together? How many? When you put the underlined x and 3x together, Colton, what did you get? How many total x's? Colton, are you there? Thank you. Perfect. You put it in the chat. That's awesome. Okay. How about the other terms? How many did we have there? Online learners, you're up. Let's see. How about Brandon? Brandon, how many x squareds did you get? Okay, so please work on that, finish it. He wants me to ask Nick really bad. Nick, what did you get? How many x squareds? No. Okay, how about Ethan Garrett's? Are you guys following along? Are you doing the problems with us? Okay. Well, if we look at our signs out in front, what are the two values you can punch into your calculator? Grace, what would you punch into your calculator?